Welcome to Ask and Learn.
Okay, so this problem is about burning gasoline. You have this much heat when it's burned at this temperature. The car is efficient. Engine is 25% efficient. 3/4 is expelled into the air, typically at 20 degrees C. You get 35 miles a gallon. How much does your car's engine change the entropy of the world if you drive a mile? Does it increase it or decrease it? So thinking of the car kind of like a heat engine. So I'll draw simplified car. And then I'm kind of pretending that the gasoline is external, but of course it's kind of in a compartment. But nonetheless, I can write it like this. So Q hot goes in, Q cold goes out, and then the car sort of goes along. So the goal is to get the change in entropy in the universe. So you can kind of think of this as getting the change in entropy due to the heat flow out of the hot reservoir, plus the change in entropy due to the heat flow from the cold reservoir. So heat flow is flowing out of the hot reservoir, so you want to do minus Q hot divided by T hot, and then plus Q cold over T cold, and that's positive because heat's flowing into it. And so you want to get Q hot. I'm just going to go ahead and start using the numbers here, just because I don't want to kind of come up with all these new names. I think it will unnecessarily complicate things. So that's times 10 to the 8 joules per gallon times, and then you can, for 1 gallon, you have 35 miles. And then you want to go 1 mile. Great. So that's your Q hot. Oh, and then I'll show you how the units cancel just to make sure we have something in units of heat. So gallon, gallon, mile, mile, boom, we have joules if we multiply that. And then T hot is 400 C, but we want to, of course, add 273. Never want to use Celsius unless we're doing temperature differences. So that's like the first term. I'll just kind of put like a little blue underline just so that that's like visually sort of clear. Okay, and then plus Q cold, so only 75% is like getting expelled. So it's basically just 75% of this like whole thing. So 1.23, and it's like the same exact calculation, right? So I'm just gonna write it like this, but same number. And then now, but this reservoir is at 20 degrees C, so it's 20 plus 273 Kelvin. All right, and so you basically need to just sum these two terms. Here, I'll just to make it clear and symmetrical. There we go. So if you sum these, plug in all your numbers, then maybe you'll get what I got. No, it didn't start with a 6. It was positive. Sorry. 3770 joules per Kelvin. Oops. There we go.